Good morning, everyone. My name is Anthony Percival, and I did my literature review on green roofs to support urban biodiversity and habitat connectivity in the face of urbanization. So, the first thing I want to do is talk a little bit about urbanization as a whole and its threat to global biodiversity. So, urbanization is the transformation from a natural landscape to an urban one. That can be a forest to a city, that can be wetlands to suburbs, that can be building highways through mountainous areas. And what's important is it's not an equal global occurrence, and that urban populations are increasing. And with those urban populations increasing, you're going to have increased extensification of urban areas, that is, extending out from the city center, and intensification, which is up or down. And what's especially important for biodiversity is that around the world, in these biodiversity hotspots, these areas of very high biodiversity, you have 5.8 million square kilometers that have a positive probability of being developed. And that's just anywhere greater than 0%. That may not seem like a lot, but this is a little bit more worrisome. 1.2 million square kilometers have a 75% probability of development. And if these projections go as well projected, we are expected to lose 40% of species in those biodiversity hotspots. You do not need to destroy much of a habitat to severely affect the species that live within it. So, this is a kind of good way to look at areas at risk globally. And you can see areas within countries highlighted. So, what's important to look at here is that even if a country has a low overall rate of development, areas within that country, represented by the red, have a much higher chance of being developed, while areas in the yellow are much lower. So it kind of shows us that it isn't enough just to look country by country. We need to look within those countries at those sensitive areas to see what is under threat of being transformed from that natural biodiversity supporting environment to the urban environment. But going from the perspective that we will continue to urbanize environment, we will continue to extensively change that landscape, how can urban areas support biodiversity? And what kind of biodiversity exists in urban areas? Urban areas are the most rapidly expanding ecosystems. They're one of the only probably expanding ecosystems. But they're also highly managed, and there's heavy fragmentation of habitats, which is generally not good for species. It limits movement, it limits space, it limits resource acquisition. What do we know about urbanization and fauna? We don't know a lot. Overall, you see increased abundance, which is just the number of individuals of a certain taxa or a certain community. But we see decreased richness. This means the diversity of species goes down, even if the number of individuals goes up. That's why you see hundreds of thousands of pigeons in New York City. That has a very high abundance, but it's only one species. And urbanization and flora. This is kind of interesting because we pretty much destroy a natural environment and then build our own on top of it. So we dictate the types of plants and the general flora diversity in an urban area, and it depends on all of us. If we're homeowners, if we have land, if we can control planting, we may decide to plant a monoculture of grass. We may decide to plant a pollinator garden, a series of trees and shrubs. We may utilize natives, non-natives, and those species that are considered invasive. And it's not just us. There's corporate property and government property that all influence the diversity of plants within an urban environment. And this creates that high heterogeneity. You're going to have parking lots next to a pollinator garden. And our plant selection sets the stage for whatever else is going to live in that urban environment. Based on what we decide to plant, that will affect what fauna is able to exist, both micro and macro. And after we kind of set that stage, that's when we start to see those ecological processes take over, that acclimatization, that adaptation to our urban environment. And that has to do with stuff like plant succession, maybe a very important pollinator species moves into the area and that facilitates a certain species of butterfly or bee. And what's even cooler is that rare plants have been found in existing urban environments. So maybe that means urban areas are useful for supporting biodiversity. Maybe it's possible. And I want to take a little moment to say, why should we care? Because that's a big argument. Why do we care about biodiversity? And it's a good question. It's hard to put a concrete value on a specific species. But there are reasons. You could have ethical and moral reasons. Maybe you have a general respect for the planet. Maybe you think that life other than humans are important. Many religious and secular teachings advocate for good environmental stewardship. And there's also benefits to humans. One of the biggest things is that by protecting the habitat that species live in, we also protect those ecosystem processes like nutrient recycling and those ecosystem services like stormwater management, one that we've talked about extensively throughout this semester. Additionally, there's the psychological and physiological benefits to protecting biodiversity around us. We've talked about that throughout the semester, and there's education opportunities. This kind of gives a good little continuum of that. Everything from preserving biodiversity to creating habitat connectivity, that stepping stones are corridors for natural populations. We become connected with the environment. We fulfill ethical responsibilities. We get ecosystem services. We generally improve human well-being. So there is motivations for protecting biodiversity, both within urban environments and outside of them. But green roofs apply specifically in this case to protecting urban biodiversity. How can green roofs help with biodiversity and habitat connectivity to support those species? This information is from a review by Williams, and it kind of summarized a lot of the knowledge before 2014. An important thing he found is that a lot of companies that supply green roofs argue that, or supply as an argument for choosing their company, that biodiversity is supported by their systems. Unfortunately, there might not be as much research as we thought at the time to really back that up. So it was kind of an unfounded claim at the time. But in this review, the author did find that green roofs support more biodiversity than conventional roofs. So the companies weren't really wrong. They weren't really right, though. More evidence is required to say whether green roofs are useful as at-grade green spaces. This is very important because this provides evidence that you should not be able to destroy a natural environment and say, oh, we'll just replace it with a green roof. We don't have enough information to say that it's as supportive. There are conflicting studies on the usefulness of sedum roofs versus greater floral diversity roofs. But we're going to go into that a little bit more in a few studies I have prepped. So that's kind of exciting news. And green roofs have been shown to aid in rare species conservation. One thing that's super important about this is that green roofs may be useful for habitats for a species, but it may not be throughout their entire life. This also has limitations as far as taxa are concerned, and that you can't just have one green roof in the middle of a city and expect it to save the biodiversity in the area, because connectivity is important for those species that can't just stay in one place for their entire life cycle. So the first study I want to look at is by Bracker et al., and he looked at 40 green roofs and 40 at-grade analog spaces in Zurich, Switzerland. And what these authors were concerned with is how do local environment conditions of green roofs and the connectivity of those green roofs affect both mobile and immobile or low mobility arthropods. And they looked for high mobility species, they looked at bees and weevils. For low, they looked at carabid beetles and spiders. And as you might expect, they found that low mobility species depend more on local environment conditions, while high mobility species depend more on that connectivity, because they're more dispersal species. They also found that size of the green roof wasn't necessarily that significant to community composition, but good vegetation cover was, which means you might be able to have a lot of small green roofs throughout a city to support biodiversity. And roof communities are more sensitive to fragmentation than at-grade analogs. That means that if you have a system of green roofs, they may need to be closer than a system of green spaces at grade to really support those urban communities. So overall for this study, green roofs are useful as habitats for urban species, and they may be valuable stepping stones for highly mobile species, as well as species moving from natural environments to urban, through those urbans to other natural environments. So, continuing on that study, Bracker et al. Wanted to look specifically at species and functional diversity. Now, to differentiate these two, species diversity is basically that species richness. How many species are in an area, and how is that spread out? And functional diversity is it is what it is. It's a diversity of function of those species. That can be pollinators or parasites or carnivores or herbivores, stuff like that. And what they found was that although species richness was lower on those green roofs, so the total number of species was lower, but the functional diversity didn't differ. They had an equal amount as the at-grade analogs, which is important to say because we know that those harsh habitats of those green roofs don't support as much life as the at-grade spaces, but they still have all of those functional characteristics of an at-grade environment. So they exist as their own ecosystems. The proximity to the nearest green roof was important for mobile species, once again, and the presence of ground nesting bees was positively associated with green roofs, and that had to do with both substrate and floral diversity. It turns out the ground nesting bees really like that green roof aggregate, especially if it's made up of finer particles. There was also a high correlation between generalist species on green roofs. That means species that can take advantage of multiple pollinator plants or multiple environments. They don't need a super specific environment to survive. So overall, for this study, green roofs can serve as habitats as well as harbor high functional diversity, potentially making them functional habitats in and of themselves. So McKinney et al., moving away from bugs, looked at snail abundance and diversity on green roofs. My first thought for this was, how does a snail get on a roof? But we'll get to that in a moment. So he looked at 27 sites on the southeastern United States: Knoxville, Chattanooga, Nashville, Atlanta, Charleston, and Savannah. And all of these sites were highly heterogeneous, which means that some were highly managed, some were not managed at all, some were big, some were small, the types of plants differed. And what they found was that there were 466 total snails on those 27 green roofs, which doesn't seem like a lot, but it was 18 species, and a fourth of the roofs didn't even have any snails. They found that higher abundance and richness were on high maintenance green roofs, so the ones that were weeded and watered, and that plant diversity wasn't significant, but vegetation cover was. And I think it's important to take away from this that this may just allow those snails to survive in the hot summers of the southeast. That irrigation, that vegetation cover gives them shelter, gives them just a way to exist. So here we come to how the snails got on top of the roofs, the influence of the horticulture trade. So the species composition on the roofs were found to be similar to greenhouse and nurseries, and there was little similarity to the nearby at-grade sites, meaning that snail abundance on green roofs really might depend on human transplantation. One fun example is the zoo in Atlanta, because they haven't had a replanting in 22 years, which means that the snails that were initially brought over were the only ones that were there, and the zoo, the Atlanta green roof, had a very low number of snails compared to other green roofs surveyed. So now I want to talk about bees just a little bit. I know I'm starting to run low on time. I might go a little bit over, sorry. So they looked at wild bee abundance and diversity on 9 green roofs in Vienna. The roofs hosted 90 wild bee species, which is a 1/5 of Vienna's bee diversity, which is pretty good for a roof habitat. And diversity and abundance was positively linked to floral resources and fine aggregate. Once again, those bees like that fine substrate. Most of the bees found were generalists, but greater floral diversity was associated with pickier species. That means species that maybe only want to collect pollen from one type of plant. Height didn't affect the abundance or diversity of bee species, but it did affect the size. As green roofs were built on higher and higher buildings, bee size decreased. Oh, excuse me. Something really important they found, though, was that sedum and wildflowers were found to be equally important in supporting bee species because they flowered at different times. The sedums flowered in June, the wildflowers in April, May, July, and August. They work in complement with each other. So something to take away from this is sedums are great for generalist bees, but you can get more diversity of those wild bees with floral diversity. I didn't mention this, but I wanted to highlight that this study is specifically on wild bees and not like your cultured honeybees, but they did find honeybee presence, but it didn't negatively affect the wild bee presence. So the last study I want to talk about is exclusively about the plants. So they were looking at genetic diversity of this self-compatible forb, this Penstemon hieristus, which is a common green roof plant capable of self-fertilization. They were worried because many green roof plants come from nursery stock, and if they all come from the same nursery stock with that same genetic diversity, they may end up with what's called an inbreeding depression, which is just a reduction in the number of genes that can lead to a lower fitness, which means that the species will not be able to reproduce as successfully as competitors. Um, we also know from past research that urban species have a lower pollination visitation rates. So the study was done on green roofs in Chicago and Glencoe, Illinois. And what they found was that the nursery stock plants used on the green roofs did have a lower genetic variability than nearby natural populations. But there was sufficient gene flow between green roofs across the city to support 1/4 of plant offspring being from green roofs that were roughly 127 meters apart, meaning that this is enough to avoid that low fitness risk from inbreeding depression and that long distance pollination across urban environments does occur. This means that this may support both pollinator species and the genetic resilience of those plant species that we decide to put on green roofs, which is going to create a higher resilience to any kind of environmental stress or stochastic change, like, I don't know, something like a hailstorm. So that's all the studies I have, and I wanted to talk about my conclusions for a moment before ending this. Once again, I'm sorry I'm running a little bit over time. So overall, green roofs have been found that they can act as a habitat for a diversity of species. And in this review, I mostly focused on arthropods. There were some snails and some plants, but it was mostly bug species. There's a lot more to look into with mammals and birds, but there was just not enough time in the day. There is evidence to indicate movement between green roofs and some evidence for movement between green roofs and sites at grade, which means that a good connectivity of sites at grade and green roofs is a good way to transferring into a very environmentally biodiversity friendly city. There is support for long range pollination, which means the green roofs may not have to be as close as we think. Green roofs are unlikely to replace habitats lost due to urbanization from current research reviews, but it doesn't mean they can't complement that habitat connectivity. Roof habitats may be taxa or community specific. This is really important in development. If you want to support butterfly migration, you need to build your green roof to support butterfly migration. You can't just put a random assortment of vegetation on a roof and say, oh, there's plants, so this is going to support X, Y, and Z species. You need to understand the ecology and physiology of species and communities before you decide how to build your green roof. And that involves incorporating green roof engineers, roofers, ecologists. It's going to be, I think, a very transdisciplinary science as we move on with that green roof culture. And that's all I've got time for because I'm getting close to 19 minutes. I want to say thank you all for watching and listening. I'm really excited to look at all of your presentations, and I'm going to go through my references really quick just so you can take a peek if you were interested in looking for any more information.